Hey folks, we are starting a new module. The new module is dealing with these things called rationals. You've got rational functions, you've got rational expressions. Basically, it just means a fraction, uh, usually with a variable. I guess it doesn't have to be a variable. But so we're going to start off by multiplying and dividing them today, as you can tell, and then we're going to move on to adding and subtracting them tomorrow. And then later on in the module, we're going to start graphing them. So yeah, let's start with today's pretty straightforward, just multiplying and dividing. So the nice thing about multiplying is you can just multiply straight across. Fractions don't need a common denominator if you multiply. So I don't really care that these don't match up. When we get to adding and subtracting, it will matter. So when you multiply straight across. 5 times 6 is 30. I'm just going to kind of then look and group things on the top that I can put together. Usually you want to go in alphabetical order. So I caught that there's this W, and there's only 2 of them, so I'm going to have W squared. Then I'm going to move on to the x's. So I got the numbers taken care of. I've got W squared taken care of. X would be next, and there's only 4 x's. And now we move on to where we've got groups of them, more than one. So you want to add these exponents together. Remember, when you multiply, you add exponents. So if there isn't an exponent, it means an exponent of 1. So I have 1y here, and I have 4 y's here, so that gives me a total of 5 y's. And I like to cross them out so I can keep track of where I am. And then I look at my z's. I've got 2 z's here. I've got 3 z's here. So I'm going to have 5 z's over. And I'm going to do the same thing on the bottom. So let's start off with 3 and 15. 3 times 15 is 45. Then I'm going to look for any w's. I've got 1 w. And then I'm going to look for x's. I've got 3 here and 4 here, so that's 7 altogether. And I like to cross them out. You don't have to. I look at my y's. I've got 7 here. I've got 2 here, so I've got 9 altogether. And then it looks like I have z to the 6th. All right, now I'm going to simplify this. In a perfect world, you'd look at the 30 and the 40. Usually what I do in these situations, I start off by just drawing a new fraction bar because I'm going to have stuff left on the top and on the bottom. So if it's easier for me to understand it, I just draw a new fraction bar. And then I'm going to start to look with the numbers. So in a perfect world, you'd look at 30 and 45 and try to find their GCF, the greatest common factor. We also have this sort of way to kind of cheat the system a little bit. You will be able to do this part on the test. Is I'm going to make a fraction here. There it goes. I'm going to type in 30 over 45. And what's nice is it simplifies it for us. So hopefully you saw that 15 is the GCF of 30 and 45. But if you didn't, you can ask your calculator to do the work for you. So anyway, we figured out that this simplifies to be 2/3. Then I'm going to look at the variables. I'm going to decide, are there more? How many more are there and where? So if we look at the W's, there's 2 on the top, there's 1 on the bottom, so that means there's 1 extra on the top. Then I look at the X's. There are 4 on the top, there are 7 on the bottom, so there are 3 more X's on the bottom. The Y's, there's also more on the bottom, there are 4 more on the bottom. The denominator, I probably should say. And then I look at my Z's. I've got 5 Z's on the top, 6 Z's on the bottom, so I'm going to have an extra Z on the bottom. If it helps you to put the 1 there to understand it better, you can, but don't put it in the computer like that. I don't think the computer will accept that. That's what we call simplified. So we did a multiplication. Now we're going to move to division. Nobody in the world can divide fractions. So what we do instead is we flip and multiply. What I mean by that is I'm going to turn this into a multiply problem. So I'm going to make this a multiply dot, but then I have to flip this fraction over. So what I usually do is I write the denominator on the top, a to the 8th, b to the 3rd, c to the 3rd, d to the 7th, and then I cross that out. Write it down before you cross it out so you can actually see what's there. I'm going to do the same thing with this numerator. I'm going to flip it to the bottom, so this becomes 35, a to the 4th, b to the 9th, c to the 6th, cross that out, and then this becomes the exact same problem as up above, just with different numbers and letters. So I'm going to start off, 21 times 3 is 63. A's, there are 4 here, there are 8 there, so there are 12 A's. There are 3 B's and 3 B's, so that's 6 B's. C to the 6th, C to the 3rd is C to the 9th. And it looks like there's only D to the 7th. Over, I'm going to clean up the bottom now. 4 times 35, oh, I could probably do that in my head. 35 and 35 is 70, and then 70 and 70 makes 140. Then I look at the A's. It looks like I have 4 A's. I have 2 B's and 9, so that would be B to the 11th. C to the 3rd and C to the 6th would be C to the 9th. And then looks like D to the 5th. I guess I didn't cross them out like I did last time. If you like that crossing out process, feel free to cross them out. I guess I didn't need it this time. So now I'm going to start off with 63 and 140. Hopefully you see that 7 goes into both of them. If not, you can always go back to your calculator like I did before, and I got 9 over 20. So I usually start off by giving myself a new division bar, 9 over 20, and then I just start looking at stuff. There are 8 more A's on the top, so I'd have A to the 8th. There are 5 more B's on the bottom, so I'd have B to the 5th. There's the exact same number of C's, so there's none left. So C to the 0th is what we would have, but remember C to the 0th is 1. When you multiply by 1, it doesn't change anything. And then I look at the D's. I have 7 on the top, I have 5 on the bottom, so I have 2 extra. Box it in, put it up on my fridge. There's 2 more examples. If this was class time, I'd have you do a U-try there, but you're going to have some practice on the homework. So I'm going to move to the next part. This is where we've got functions that aren't connected by multiply. So the only way to cancel something in a division problem is it's got to be a multiply problem. So I have to turn this into a multiply problem, and the way hopefully your math voice looks at this and thinks, it should be thinking X factor. So what I'm going to do is I'm going to try to X factor the top and the bottom and see if anything cancels. So let's start with the top. So I start with the number out front. I multiply by the number at the end. 1 times negative 14 is negative 14. I've got a 5, goes in the middle. What multiplies to negative 14 and adds to 7? Sorry, adds to 5. I was thinking ahead. It'd be 7 and 2. But I need it to be a 5, so it'd be a negative 2. All right, so here's your quick review of how factoring works. I'm going to start off the problem. Once I complete the X puzzle, I'm going to start off the problem with what I know every answer to a factoring problem looks like. This thing times this thing has to make that. And then at the same time, this times this and this times this have to make these two. So this one's pretty easy because I have to build a 1, so they both have to be 1s. And then I'll use the 1 to build a 7. I'll use the other one to build the negative 2. All right, so now we look at the denominator, and we've got a problem in the denominator that you have to be ready for. You cannot factor if the leading term is negative. So we can't X factor if there's a negative here. So we're going to GCF that out first. You must GCF the negative. So if I GCF out a negative, I'm going to take out a negative 1. That would leave behind an h squared. That would leave behind a negative 7h, and that will leave behind a positive 10. Now this negative 1 is going to carry over, so I'm just going to go ahead and put that over there right now. And then I'm going to look at this, and my math voice says X factoring. So I'm going to start up another X factoring problem. You're going to be doing a lot of X factoring this module. All right, so I've got a 1 times a 10, so we've got a 10. We need to build a negative 7. It's 5 and 2, but they both need to be negative. So now I'm going to go up here. I'm going to create the spaces that I need because I know what a factoring problem X factoring problem looks like. This spot times this spot has to make that. And then at the same time, these two need to multiply to make these. Again, pretty easy one here. I've got 1. I've got 1. I'll use this one to build a negative 5. I'll use this one to build the negative 2. Okay, now we've factored. Now we're going to clean up. So now as I'm looking at this, I'm looking for anything, just like we did on the front, that's the same that I can cancel out. And if we see, I have 1h minus 2 and I have 1h minus 2. So those two chunks are going to cancel each other out. And then from here, like I said, you want to, each new step, you want to just draw a division bar and write what's left on the top and what's left on the bottom. So I have 1h plus 7. I would just write that as h plus 7. But the computer might care. I'm actually not sure if it would care this time because of equivalency, but that's all right. And then on the bottom, I've got a negative 1. And then I've got this group, h minus 5. Now notice I didn't need the parentheses on the top. I could put them there, but I didn't need them because it was just h plus 7. I do need the parentheses on the bottom because of the negative 1 and the h minus 5. Okay, so that's the big idea. Now I'm going to do a couple more examples with you so we can get some practice in, but that's basically what we're doing. So I'm looking at these problems, and I would encourage you to pause here and see if you can factor this stuff. Actually, pause and just see if you can write down what kind of factoring it is. All right, let's see how you did. So as I look at this is an x factoring. There's only 2. It's not SOAPs or dopes because it doesn't have a squared, so it must just be a GCF. There's got to be something that I can take out, and yeah, 3 goes into both of those. I move on to this. This is x factoring. It's actually a special case of x factoring. I'll remind you of that in a minute, but it's x factoring. I move on to this. This is dopes. Dopes means difference of perfect squares. And I recognize that it's only 2, and I recognize that it's an 81, which is a perfect square. This, again, is x factoring. So let's do that. Give myself a division bar, start to factor this stuff. So GCF, I don't need to do an x factor on that. GCF, there's a 3 in common. I'm going to take out a 3. That's going to leave behind an x and a 5. Dopes, I also don't need to draw an x for that. That's x plus 9, x minus 9. And then these two x factors. Okay, so this is 1, this is 81. That means needs to make negative 18. That'd be negative 9 and negative 9. This is an easy x factor, again, because that's a 1 out in front. So I'm going to have an x and an x. And I need to build a negative 9 and another negative 9. So not very interesting. Okay, this one is a negative 45. That needs to build a negative 4. 9 and 5. Yep. So it'd be 5 and a negative 9. And again, this is another nice x factoring problem because the coefficient is just 1. So it's got to be 1 and 1. I'll use this one to build the 5. And I'll use the other one to build the negative 9. And then from here, I want to see if there's anything that cancels. And it looks like there's lots of good stuff. So x minus 9 for an x minus 9. You can only trade 1 for 1. Even if there's more than 1. Let's say this one wasn't here. You could still cancel this. You just wouldn't be able to cancel this. But in this case, there's 1 for each of them. So 1 for 1, 1 for 1. Plus 5 cancels out. And I'm left with, again, the new fraction. Looks like there's a 3 on the top and an x plus 9 on the bottom. All right, so for the next one, it's the same basic idea. There are some tricks that I want to put in the mix here, though. And the 2 tricks are when things are backwards. This is backwards. We consider this to be the correct order. We call it standard form because it starts with the highest exponent and it goes downhill. So x squared to x to no x. X squared to x to no x. These 2 are backwards because the no x comes before the x. This is backwards because the number comes before the x squared. So these are both backwards. But how we handle them is different. So this is backwards. This is backwards. In this case, this is an easy fix. This just becomes x plus 5. And that's because addition is what we call commutative. If you did 5 plus 7, and then I did 7 plus 5, we're going to get the same answer. So if I put the number 7 in for those x's, it's going to give me the same answer. So I'm allowed to just flip it around. No biggie. This is a different situation. Subtraction is not commutative. So if I did 7 minus 5, I would get 2. But if you did 5 minus 7, you would get negative 2. So it's off by a negative. So if you're separated, if you're backwards and you've got a negative in the middle, a subtract in the middle, you've got a GCF out a negative 1. So look what happens when we take out the negative. The 64 was positive, but if I take out a negative, now that's negative. And then the x squared was negative before, but when I take out the negative, now that's positive. So be careful of those. If you see something that's backwards, not in standard form, you've got to flip it around. If it's all pluses, you can just flip it around, no biggie. If there's a subtract involved in it at all, you have to take out a -1 to flip things around. Then we could finish that, but it's basically the same problem as up above. So let's jump to the new one and look at each thing. So what I'm going to do first is I'm going to go through and see if I've got anything that's weird or backwards or something that I need to fix. And there's a lot that I noticed. So the first thing I noticed is that this is a multiplication problem. Sorry, this is a division part, and so I'm going to fix that. To fix that, you need to flip things around. So I'm going to reciprocal. I'm going to turn this into a multiply problem, and I'm going to reciprocal this, which means the bottom becomes the numerator becomes the new denominator. So I'm going to take this, I'm going to flip it up. So this would be 2x squared plus 11x plus 5. And then I'm going to cross out that old denominator because that's my new numerator. Then I look at this is my new denominator, but this is backwards. See how the x squared is at the end? But what's nice about this is everything is an add. So if it's add, I can flip things around, and I can change the order without having to do anything. So this becomes 3x squared. This is still 10x, and then I'm going to put the 8 at the end. So I put the 3x squared, it's still positive, and then the 10x and the 8. That's now in standard form. I look at this, I like that, that's fine. I like this, that's fine. This is backwards. Now this is backwards and it's got a negative. So the only way to fix it is to take out a -1. And then I want to put things in order, in the proper order. So if I want this thing to be first, but it's negative, so I had to take that out. So now it's positive. But I took a negative out and I've got to take it out of everything. So instead of being 6x, this is now subtract 6x. And instead of being 5, this is now subtract 5. I like to cross out the old stuff so I don't get confused, but you don't have to cross it out if you don't want to. Then I look at the next one. Again, this is backwards. It's 25 minus x squared. It's supposed to be x squared minus 25. So I'm going to take out a negative. Now remember, this is still separated by multiply, so don't get those two things confused. If I take out a negative, the negative x squared becomes the positive x squared, and the positive 25 becomes the negative 25. And I like to cross things out. Now from here, I'm going to look. I've got everything in the right order, quote unquote. Those negatives are going to cancel out. I'll deal with that later. If you want to get rid of them right now, you can. A negative times a negative is a positive, but like I said, we'll deal with that later. I'm going to go through and say what kind of factoring everything is. So this is an x factor. This isn't an x factor because it doesn't have 3, and it's not dopes because these aren't perfect squares. So this has got to be a GCF. This is another x factor. This is another x factor. This is dopes because 25 is a perfect square. And then this is an x factor. So I'm going to have to make 4 different x's for this one. Now this is kind of tedious, but you just got to take your time and make sure that you're cleaning things up correctly. So we're going to start with 12 times 20. What am I doing? Why would I pick such big numbers? So that's negative 240, and then it makes a 1. Now remember how to do this. If you can't do this off the top of your head, which I can't do with negative 240, I got to go over here and I've got to make a chart. We call these factor pairs of all the numbers that make negative 240. So 1 and 240, 2 and 120, 3 and, would it be 80, I think? Yeah, 80. 4 and 60, 5 and, let's see, 5 would go into there. 12 times 5 and 48. I'm going to double check that one. Yeah. 6, so that would be 10. 6 and 40. 7, I don't think 7 is going to work, no, because it doesn't go into 24. 8, so I go back to the 4. One way you can kind of cheat here is if 4 works and the number's still even, that's going to be what 8 is. So I'm going to change that to a 8, and I'm going to divide this by 2, so that's a 30. 9, 3, and then this isn't still divisible, so 9 doesn't work. 10 and 24, oh boy. 11, 12, and 12 is going to work. So 6 is still even, so that's 6, that's 12 and 20. 13 doesn't work. 14 doesn't work because 7 doesn't work. 15, 5, and, oh yeah, because 5 is still divisible. That's still divisible by 3, so it'd be 15 and 6. Oh, there it is. I've completed my list, and it was the last one that I found. So 15 and 16 multiply to make 240, and they can combine to make add or subtract to combine to make 1. So I'm going to have, I need a positive 1, so that would be a 16 and a negative 15. All right. So over here, I'm going to start my first fraction. I need to make 16 and 15. So I'm going to start off with my spaces. There's x, there's x. So remember, circle times circle has to make circle. So these two numbers have to multiply to make 12. And at the same time, these two spots have to make these two numbers. So let's see, 12 could be 12 and 1. No, that doesn't work. It could be 2 and 6. 2 could make this, but 6 can't make that, or vice versa. So it's got to be 3 and 4. So this is going to be a 3. This is going to be a 4. I'll use the 3 to make the negative 15, so that's a negative 5. I'll use the 4 to make the 16, so that's positive 4. Over, and like I said, I'm going to get rid of these negatives now. Negative times a negative is a positive, so I can just cancel those two things out. Okay, our next x factoring. So 8 times negative 5 would be negative 40. That makes negative 6. This one's a little easier, 10 and 4. So 4 and negative 10. I'm not going to draw the circles and stuff. I'm just going to do this part in my head. So multiply this times this has to make 8, but they also have to make 4 and 10. So 8 does not work. 2 and 4 is what I need. I'm going to put a 2 there. I'm going to put a 4 there. The 2 could build either of these, so I'm not going to use the 2. I'm going to use the 4. The 4 can only build the 4, so this needs a 1. And then this needs a, that's going to the 4, that's going to be a negative. I like that. Those are going to cancel later. All right, we keep going. Move on to the next one. I don't need any x's for the next part. This is just a GCF. So these both have, let me zoom out a little bit. These both have an x, so I'm going to take out an x. That leaves behind an x plus 2. This on the bottom is dopes, x plus 5, x minus 5. And then I move on to my last factoring. Don't forget, this is my new numerator, so I'm going to do 2 times 5 is 10. That makes 11. Well, that's 10 and 1. So if I got to build a 2, it's got to be a 2 and a 1. I'll use the 2 to build the 10, so that would have to be a 5. I'll use the 1 to build a 1. They both need to be positive. And then my last x factoring, 3 times 8 is 24. That needs to make 10. Ooh, be careful on this one, because there's 2 that could work here. 6 and 4 and 2 and 12. 12 has to be with a negative 2, and then 6 would have to be with a positive 4. So yeah, no. They don't both work. 12 and negative 2 would make a negative 24, so those don't work. So we got a 6 and a 4. All right, it's a 3, so that's nice. That's got to be a 3. I'll use the 3 to build the 6, so that has to be a plus 2. I'll use the 1 to build a 4. All right, that's tedious, but we've been factoring a lot, so hopefully that's not too painful for you. So then what we're going to do now is we're going to go through and we're going to see what cancels, if we can find anything in common. So we found this one early on, 4x minus 5 and 4x minus 5. Let's see, 2x plus 1 and 2x plus 1. 3x plus 4 and 3x plus 4, x plus 2 and x plus 2, x plus 5 and x plus 5. Well, we did pretty good. So overall on the top, we just have an x left over. On the bottom, we have an x subtract 5. Okay, so that's it for notes. The homework is basically the same stuff. You just got to make sure that you're taking your time and you're factoring properly using your x factoring, and then just see what stuff cancels.